Hello and welcome to another reaction video. This one will be still in line with the alkene addition reactions, and this one will have to do with hydrogenation and hydration of alkenes. So this is the first reaction I'd like to talk about. This is the hydrogenation of an alkene and its overall transformation. So you begin with an alkene, either cis or trans, it doesn't matter, and you'll end up with an alkane of this alkene. And to do that, hydrogen in its diatomic gaseous state is added. And with a catalyst of platinum on carbon, you can transform this alkene into an alkane. Now this is the other reaction. This is a hydration reaction. This is when you would like to transform an alkene into an alcohol. And in order to do that, you just simply add water, and over time, it will happen. So this is the general mechanism for the hydration reaction. And as you can see, the double bond will the electrons from the double bond will attack the hydrogen on water, which will then displace electrons from the bond into the oxygen, and will leave you with a hydroxy group. Now what you're left off with is a carbocation in its most stable form. There are rearrangements that can happen here, and the hydroxide will then attack with its electrons on that carbocation and then leave you at the end with the alcohol. This is an example of a hydrogenation reaction of a cyclohexene, and you can just have the beginning and as well as the products. So the reagents and products as well as the initial alkene in order to show the full transformation. There is no mechanism needed because it's very complex, and if you're just studying organic chemistry, that's, at the undergraduate level, it's not important. However, this one is important. This is the an example using 3-methyl-1-butene, and it's the hydration mechanism that is shown. So, as mentioned earlier, the electrons from the double bond will attack one of the hydrogens on the water, and then the bond, as a new bond is formed with the hydrogen and the carbon where the alkene formerly was, will now have one of its only bond to the oxygen have the electrons associate with the oxygen, creating an anion of hydroxide. And this carbocation will then move in the next step to its most stable form, which is at the 3' carbon rather than the 2' carbon, as you can see. And then the hydroxide will attack it and create a tertiary alcohol. Thank you for watching.